Hey class, welcome back to the cheat sheet for the problem of the day for week 4. We're on page 2 now. So example 2. So we got our girl Reve, and what we see here is that she is throwing the ball in the air, and based on this quadratic function here, the ball is going to start at 5 and go up in the air at a rate of 40 meters per second. And we have our nice parabola or quadratic right here. Now, ultimately, what do we want to know? Well, we want to know the initial height. We want to know the vertex, and we want to know where it hits the ground. So, one of the things that I always do is think about where I can get those 3 pieces of information. I'm going to invite you to do that right now. Think about it. Come back to me in about 30 seconds. Pause the video. All right, welcome back. So we've been thinking about how I could identify my 3 points. Very important. Okay. So let's see what we're working with here, okay? So my very first point, my initial point, is going to be 0.5. So I'm initially going to start at 0.5. And then my goal is to identify where I'm going to hit the ground, okay? So 0.5 is where I start. Where I hit the ground is approximately 5 seconds. Now, how am I getting that information? Well, I'm doing a couple of things, guys. First thing, after I get it into my calculator, I want to be mindful of the fact that I may not always have a whole number. And if I don't have a whole number, I may not find my zeros. So I want to do something really, really cool that I want to share with you right now. So here's what I want to share with you. Once I get this equation in my calculator and I hit graph, I have some options. Well, first option is I can make it look a little nicer. One of the things I always try to do is hit zoom 0, zoom fit, enter. And no matter what it looks like, it allows me to kind of be able to see everything. But I want to hit zoom out just because I want to see where it comes back to the ground. Okay, all right. So one thing I'm going to do is we've done second trace 5 forever to get intersections. Now I want to do something called second trace 0. And I think it's going to come back to the ground. Well, I know it's going to, start be somewhere between 0 and based on what I kind of already know is going to be between 0 and say 6. Now, where did I get 6 from? Well, because I worked it out already. I know it's roughly close to 5. But so here I am, it's between 0 and 6, and I'm saying, well, guess, computer, please make a guess. The computer guessed, and it gave me 5.11 is when it comes back to ground. Now, I would not have gotten that if I only relied on my table, because obviously you guys see whole number, all right, is going to give me 5. I needed a decimal. So that's a nice thing to know about. So I got 2 pieces of information. I got where I start, I got where it comes back to the ground, and now I need to know what my vertex is. Well, how are we getting our vertex? Well, something else kind of handy. I got my graph here, and now I'm just going to hit zoom fit again. And this is helpful. I do this. I say second trace, and I want to know what my maximum value is. All right. Well, I know it has to be between 0 and 5 seconds. So here we go. I hit 0 at 5 seconds. I ask the computer to guess, and the computer gives me 2.5 comma 55, or in 2.5 seconds, I'm going to go 55 yards or feet in the air. And so now I got my 3 points, 1, 2, 3. I can, kind of make a nice little connect the dots kind of thing. And it may look something like this. All right. Now, my thinking is the big picture is not for it to be perfect, but for it to give me enough to be able to answer questions that come up on the regions. So what have we done? And we've stated the vertex. Vertex is 2.5, 2.5, comma 5, 55. We've stated the starting point, and we've stated when it comes back to the ground. All right, let's take a look at our next question. And our next question, it says, our friend Cayman tosses a ball in the air in such a way where he uses or produces this equation. It wants to know A, what does the graph look like? We can do that. It also wants to know B, the vertex. We can do that as well. And it wants us to give us the vertex in the context of the story. We can do that. Take a moment, pause the video, and then come on back to me where you think you got it. Okay, class, welcome back. And so we get the equation of negative x squared plus 6x in our graphing calculator. And, where are we starting? Where's our starting point? All right, second graph, all right, 0, 0. So our origin is going to be, our 0, 0 is going to be at the origin. Well, when are we coming back to the ground? 0, 6. Okay, that's when I'm coming back to the ground, fine. Okay, well, how do I get my vertex? Well, again, we did this once, we'll do it again. We'll go, don't like the way it looks, so here's what I'm gonna do. I'm gonna hit zoom, fit, enter. Okay, vertex, I want it. I want to say second trace. I want my maximum. Here we are. And we know it's gonna be between 0 and it's gonna be between 6. That's kind of why we figure out those pieces of information first. It's going to guess for us. Okay, so at approximate 3 seconds, I'm gonna go a total of 9 feet. So in 3 seconds, my ball reaches a maximum height of 9 feet. So we've graphed this. Well, we're almost done. Let's kind of add this piece. So we've graphed this. Okay. We've found out what our vertex is, 3, 9, and we put it in context. The meaning of it is after 3 seconds, we reach a maximum height of 9 feet. Okay. All right, class. We'll come on back if you are still working through this.